So this game's very simple. All you have to do is read what you see, right? So I'm going to count you so we don't all do it together, okay? 1, 2, 3. Amazing. What about this one? 1, 2, 3. All right. 1, 2, 3. If you were Portuguese, right? How about this one? 1, 2, 3. What are you reading? There are no words there. I said read what you're seeing, right? It literally says what are reading, right? That's what you should have said, right? Why is this? It's because perception is grounded in our experience, right? The brain takes meaningless information and makes meaning out of it, which means we never see what's there, we never see information, we only ever see what was useful to see in the past, right? Which means when it comes to perception, we're all like this frog. Right? It's getting information, it's generating behavior that's useful. And sometimes when things don't go our way, we get a little bit annoyed, right? But we're talking about perception here, right? And perception underpins everything we think, we know, we believe, our hopes, our dreams, the clothes we wear, falling in love. Everything begins with perception. Now, if perception is grounded in our history, it means we're only ever responding according to what we've done before. But that creates a tremendous problem, because how can we ever see differently? Now, I want to tell you a story about seeing differently. And all new perceptions begin in the same way. They begin with a question. The problem with questions is they create uncertainty. Now, uncertainty is a very bad thing. It's evolutionary a bad thing. If you're not sure that's a predator, it's too late. Okay? Even seasickness is a consequence of uncertainty. Right? If you go down below in a boat, your inner ears are telling you you're moving. Your eyes, because it's moving in register with the boat, say I'm standing still. Your brain cannot deal with the uncertainty of that information, and it gets ill. The question why is one of the most dangerous things you can do, because it takes you into uncertainty. And yet, the irony is, the only way we can ever do anything new is to step into that space. So how can we ever do anything new? Well, fortunately, evolution has given us an answer, right? And it enables us to address even the most difficult of questions. The best questions are the ones that create the most uncertainty. They're the ones that question the things we think to be true already, right? It's easy to ask questions about how did life begin, or what extends beyond the universe. But to question what you think to be true already is really stepping into that space. So what is evolution's answer to the problem of uncertainty? It's play. Now, play is not simply a process. Experts in play will tell you that actually it's a way of being. Play is one of the only human endeavors where uncertainty is actually celebrated. Uncertainty is what makes play fun, right? It's adaptable to change, right? It opens possibility, and it's cooperative. It's actually how we do our social bonding, and it's intrinsically motivated. What that means is that we play to play. Play is its own reward. Now, if you look at these 5 ways of being, these are the exact same ways of being you need in order to be a good scientist. Science is not defined by the method section of a paper. It's actually a way of being, which is here. And this is true for anything that is creative. So, if you add rules to play, you have a game. That's actually what an experiment is. So, armed with these 2 ideas, that science is a way of being, and experiments are play, we asked, can anyone become a scientist? And who better to ask than 25 8 to 10-year-old children, because they're experts in play. So I took my B Arena down to a small school in Devon, and the aim of this was to not just get the kids to see science differently, but through the process of science, to see themselves differently, right? The first step was to ask a question. Now, I should say that we didn't get funding for this study because the scientists said small children couldn't make a useful contribution to science, and the teachers said kids couldn't do it. So we did it anyway, right? Of course. So here are some of the questions. I put them in small print so you wouldn't bother reading it. Point is that 5 of the questions that the kids came up with were actually the basis of science publication the last 5 to 15 years, right? So they were asking questions that were significant to expert scientists. Now here, I want to share the stage with someone quite special, right? She was one of the young people who was involved in this study, and she's now one of the youngest published scientists in the world, right? She will now, once she comes onto stage, will be the youngest person to ever speak at TED, right? Now science and asking questions about courage. Now she is the personification of courage because she's going to stand up here and talk to you all. So Amy, would you please come up? So Amy's going to help me tell the story of what we call the Black Mountain Bees project. And first she's going to tell you the question that they came up with. So go ahead, Amy.
Thank you, Beau. We thought that it was easy to see the link between humans and apes in the way that we think, because we look alike. But we wondered if there's a possible link with other animals. It'd be amazing if humans and bees thought similar, since they seem so different from us. So we asked if humans and bees might solve complex problems in the same way. Really, we want to know if bees can also adapt themselves to new situations using previously learned rules and conditions. So, what if bees can think like us? Well, it'd be amazing since we're talking about an insect with only 1 million brain cells. But actually it makes a lot of sense they should, because bees, like us, can recognize a good flower regardless of the time of day, the light, the weather, or from any angle it approached it from.
So the next step was to design an experiment, which is a game. So the kids went off and they designed this experiment, and so, game. And so Amy, can you tell us what the game was and the puzzle that you set the bees?
The puzzle we came up with was an if-then rule. We asked the bees to learn not just to go to a certain color, but to a certain colored flower, only when it's in a certain pattern. They were only rewarded if they went to the yellow flowers, if the yellow flowers were surrounded by the blue, or if the blue flowers were surrounded by the yellow. Now, there's a number of different rules the bees can learn to solve this puzzle. The interesting question is, which? What was really exciting about this project was we and Beau had no idea whether it would work. It was completely new and no one had done it before, including adults.
Including the teachers. And that was really hard for the teachers. It's easy for a scientist to go in and not have a clue what he's doing, because that's what we do in the lab. But for a teacher not to know what's going to happen at the end of the day. So much of the credit goes to Dave Strudwick, who is the collaborator on this project. Okay? So I'm not going to go through the whole details of the study, because actually you can read about it. But the next step is observation. So here are some of the students doing the observations. They're recording the data of where the bees fly.
That.
So what we're going to do... Is she still going up here?
Yeah.
So you keep track, please.
Wait, can you help me, Henry?
Can you help me, Henry? What good scientist says that, right?
And 2 up there. And 2.
Right, so we've got our observations, we've got our data. They do the simple mathematics, averaging, et cetera, et cetera. And now we want to share. That's the next step. So we're going to write this up and try to submit this for publication, right? So we have to write it up. So we go, of course, to the pub, all right? The one on the left is mine, okay? Now I told them, a paper has 4 different sections: an introduction, a methods, a results, a discussion. The introduction says, what's the question and why? Methods, what did you do? Results, what was the observation? And the discussion is, who cares, right? That's a science paper, basically. So the kids give me the words, right? I put it into a narrative, which means that this paper is written in kids speak. It's not written by me, it's written by Amy and the other students in the class. As a consequence, this science paper begins once upon a time. The results section, it says training phase, the puzzle, dun dun dun, right? And the methods, it says, then we put the bees into the fridge and made bee pie, smiley face, right? This is a science paper. We're going to try to get it published. So here's the title page. We have a number of authors there. All the ones in bold are 8 to 10 years old. The first author is Blackawton Primary School, because if it were ever referenced, it would be Blackawton et al., and not one individual. So we submit it to a public access journal, and it says this. It said many things, but it said this: I'm afraid the paper fails our initial quality control checks in several different ways. In other words, it starts off once upon a time, the figures in crayon, etc. So we decide, we'll get it reviewed. So I send it to Dale Purvis, who is the National Academy of Science, one of the leading neuroscientists in the world, and he says this is the most original scientific paper I've ever read, and it certainly deserves wide exposure. Larry Maloney, expert in vision, says the paper is magnificent. The work would be publishable if done by adults. So what do? We send it back to the editor. They say no. So we asked Larry and Natalie de Hempel to write a commentary situating the findings for scientists, right? Putting in the references. And we submit it to Biology Letters. And there, it was reviewed by 5 independent referees, and it was published. Okay? It took 4 months to do the science, 2 years to get it published. Typical science, actually, right? So this makes Amy and her friends the youngest published scientists in the world. What was the feedback like? Well, it was published 2 days before Christmas, downloaded 30,000 times in the first day, right? It was Editor's Choice in Science, which is a top science magazine. It's forever freely accessible by Biology Letters. It's the only paper that will ever be freely accessible by this journal. Last year, it was the second most downloaded paper by Biology Letters, and the feedback from not just scientists and teachers, but the public as well. And I'll just read one. I have read Blackawton Bees recently. I don't have words to explain exactly how I'm feeling right now. What you guys have done is real, true, and amazing. Curiosity, interest, innocence, and zeal are the most basic, most important things to do science. Who else can have these qualities more than children? Please congratulate your children's team from my side. So, I'd like to conclude with a physical metaphor. Can I do it on you? Okay, yeah, come on. Yeah, okay. Now, science is about taking risks, so this is a incredible risk, right? For me, not for him, right? Because we've only done this once before. And you like technology, right?
Yes.
All right, so this is the epitome of technology. Mm-hmm. Right, okay, now. Okay. Now, we're going to do a little demonstration, right? You have to close your eyes, and you have to point where you hear me clapping, all right? Okay, how about if everyone over there shouts? 1, 2, 3. Brilliant. Now open your eyes. We'll do it one more time. Everyone over there shout. Hooray! Where's the sound coming from? Thank you very much. What's the point? The point is what science does for us, right? We normally walk through life responding. But if we ever want to do anything different, we have to step into uncertainty. When he opened his eyes, he was able to see the world in a new way. That's what science offers us. It offers the possibility to step on uncertainty through the process of play, right? Now, true science education, I think, should be about giving people a voice and enabling to express that voice. So I've asked Amy to be the last voice in this short story. So, Amy?
This project was really exciting for me because it brought the process of discovery to life. And it showed me that anyone, and I mean anyone, has the potential to discover something new. And that a small question can lead into a big discovery. Changing the way a person thinks about something can be easy or hard. It all depends on the way the person feels about change. But changing the way I thought about science was surprisingly easy. Once we played the games and then started to think about the puzzle, I then realized that science isn't just a boring subject, and that anyone can discover something new. You just need an opportunity. My opportunity came in the form of Beau and the Blackawton Bee Project. Thank you.
Thank you very much.